As long as the sun is shining, we'll be fine. If humanity had to get all of its energy from the sun, it could do so. It's really a truly astounding amount of energy that comes at us from the sun. If you took the land area used by nuclear plants, including the stay-out zones and everything, and said, okay, what generates more power, the nuclear power plant or just covering it with solar panels? In most cases, it's solar panels, because you actually have to have a big stay-out zone. You can't just put a nuclear power plant out in the suburbs. But just to give you just a sense of how much power can come from the sun, this is literally true, what I've just said.
Swinging in the backyard, pull up in your fast car, whistling my name.
And the fundamental issue we have in energy and transport is the tragedy of the commons. We've got the CO2 capacity of the oceans and atmosphere that is unpriced, or mostly unpriced. It's almost like we're sort of dumping garbage in the atmosphere and nobody's paying for garbage collection.
So it might not seem like it, but it's the middle of the day here in Beijing. The air is so polluted that it's darkened the sky. Now, recent studies show that even breathing this kind of air for an hour can reduce a person's life expectancy by 20 minutes. It's akin to being a heavy smoker, smoking a pack and a half of cigarettes every day.
The tragedy is this accident has released enormous quantities of iodine, radioactive iodine-131, into the atmosphere, like what happened at Chernobyl, about 10% the level of Chernobyl. Iodine is water-soluble. When it rains, it gets into the soil. Cows then eat the vegetation, create milk, and then it winds up in the milk. Farmers are now dumping milk right on their farms because it's too radioactive. Foods have to be impounded in the area. And let's be blunt about this. Would you buy food that says made in Chernobyl? And the Japanese people are also saying, what, should I buy food that says made in Fukushima? We're talking about the collapse of the local economy, literally making it up as they go along. We're in totally uncharted territories. You get any nuclear engineering book, look at the last chapter, and this scenario is not contained in the last chapter of any nuclear engineering textbook on the planet Earth. So they're making it up as they go along, and we are the guinea pigs for this science experiment that's taking place.
It sort of feels a bit like we're like that. If you've seen those delayed gratification experiments with the kids, you can have two cupcakes if you wait 5 minutes, or you can have one cupcake if you eat it now.
Did you eat a cupcake?
No.
You didn't eat a cupcake?
No, I was at home.
You sure you didn't eat a cupcake?
No.
And that's actually quite a good predictor of the kid's future success. Okay. We're the kid who scarfs the cupcake in 3 seconds. You're like, but you could have had 2. Anyway, that's the sort of silly situation we find ourselves in. There are a lot of people, particularly in the US, who are vehemently against electric cars and sort of sustainable power. It's quite difficult to reason with them, actually. This actually reminds me of the tobacco industry, where for the longest time they were actually complaining that you'd see ads where they claimed tobacco was healthy for you. And then there were these reports where there seemed to be some correlation between lung cancer and smoking, and they're like, oh, our scientists have conducted experiments and they show there's no relation at all. It's complete nonsense. There are quite significant vested interests in oil, gas, and coal with enormous amounts of money. It's quite a difficult battle to fight, and you can't expect them to simply roll over and commit suicide or something. They will fight it hard, and they have been. We're taking trillions of tons of carbon dioxide that was buried deep in the Earth's crust and putting it in the atmosphere. And then some of that migrates into the oceans and causes acidification. So we're essentially running this massive chemical experiment on the oceans and atmosphere. And the reason I think that's incredibly dumb is because we know we're going to run out of that stuff anyway and have to find an alternative. So why are we running this massive chemical experiment on our oceans and atmosphere when we know we have to find an alternative anyway? It's the stupidest thing I could possibly imagine.
And we did get quite a bit of criticism at Tesla for creating the Roadster, which we did in collaboration with Lotus. People were complaining, well, why are you making this expensive sports car? With the implication that we felt there was a shortage of sports cars for rich people, and we're racing to meet that unmet need. You know, the real reason is that any car that we make at low volume, which is the first version of technology, is going to be expensive. It didn't matter what that car looked like.
So welcome to Fully Charged. I actually don't want to do this. Yes, it's set to insane. Steering mode is on sport, creep is off, regenerative braking is at standard, range mode is off, so everything is there ready to go. I've driven the car a mile and the initial feeling is it's pretty much the same as the 85 that I drive anyway, but I just point the throttle a tiny bit for one moment. So now I'm stationary on a very straight road. Oh! Ah! I can't do it. Hell. Oh! Oh! Jesus.
And then going into the future, our goal with Tesla is to keep refining the technology, increasing the scale of production, and make a mass market electric car that almost anyone can afford. That's step 3 on the strategy. So step 1 was a high price, low volume. Step 2, mid price, mid volume. Step 3, low price, high volume. So we're sort of at step 2, and now we want to progress to step 3 as soon as possible. Of course, we must find a sustainable means of generating energy as well.
How oil power gets to you. The sun shines on plankton, and hundreds of millions of years later they become oil, which gets drilled and shipped and turned into gasoline, which is pumped into a truck, driven thousands of miles, poured into the ground, and pumped back out of the ground into a car. And this is how solar power gets to you. Solar City.
I'm not the biggest fan of biofuels because I think it's difficult. You know, again, I try to look at things like just calculate the basic physics of it. I mean, really elementary stuff, and say, okay, well, what percentage of the incident sunlight is bound up in usable chemical energy, and then once you have that chemical energy, how much of that is then translated into electricity? And you have to compare, of course, that total efficiency with just having solar panels. I mean, unless I've made some really dumb mistake, which is possible, but you're about 100 times off with biofuels. I mean, at least 2 orders of magnitude. At least for terrestrial, land-based biofuels, there's no way this makes sense. You end up being around maybe 0.2% efficient in turning sunlight into electrical energy, whereas solar panels, commercial solar panels, are 20% efficient. So why would you ever do biofuels? I think that the main candidate for energy generation is actually solar. And I think the physics of this is actually rather obvious because the Earth is actually almost entirely solar powered today as it is.
We have this handy fusion reactor in the sky called the sun. Okay? You don't have to do anything. It just works. Shows up every day and produces ridiculous amounts of power.
It would be a frozen ice ball at, I don't know, 3 or 4 Kelvin if it weren't for the sun. And our entire system of precipitation is powered by the sun. The ecosystem is almost entirely 99.999% powered by the sun, except for some chemotrophs at the bottom of the ocean. It's rather obvious that I think once you try to take a little portion of that energy, and it's actually not much, and convert that into electricity for use by society, I'm quite confident that solar power will be the single largest source of energy or electrical energy for humanity in the future. If you can show people that there is a way, then there is plenty of will.
Actually, very little land is needed to get rid of all fossil fuel electricity generation in the United States. That blue square there is the land area that's needed to transition the United States to a zero carbon electricity situation. It's really not much, and most of that area is going to be in rooftops. So you won't need to disturb land. You won't need to find new areas. It's mostly just going to be on the roofs of existing homes and buildings.
And I actually think that the most likely outcome is a good one, or a reasonably good one that where there's damage, but we recover. I actually think that will occur. So I'm quite optimistic about the future. I'm not suggesting complacency in the least, but I'm optimistic about the future.
Electric car maker Tesla hopes to have 1 million of its vehicles on the road by 2020.
The highly anticipated Model X just rolled off the company's assembly line in Fremont, California.
Tesla is launching stationary batteries for homes, businesses, and utilities. The question now, is this going to be a game changer for the everyday home? Is it going to be a game changer for the power grid and how we get electricity?